Hello everyone and welcome to the lecture on Amazon Kinesis video streams. So this lecture will contain all these topics. What is Amazon Kinesis video streams? How it works? Kinesis video streams, API and libraries, producer API for sending data, consumer APIs for getting the data, data plane REST APIs, uploading to Kinesis video streams, Kinesis video streams playback. So what is Amazon Kinesis video streams? Amazon Kinesis video streams is a fully managed AWS service. You can use it to stream live video from devices to the AWS cloud. Also, you can build applications for real-time video processing or batch-oriented video analytics. You can use Kinesis video streams to watch your video streams in real time as they are received in the cloud. You can either monitor your live streams in the AWS Management Console or develop your own monitoring application that uses the Kinesis video streams API library to display live video. Kinesis video streams captures massive amounts of live video data from millions of sources, including smartphones, security cameras, webcams, and others. It can also handle non-video, time-serialized data like audio, thermal imagery, and radar data. Kinesis video streams can be configured to store media data durably for specified retention period. It automatically encrypts stored data and time indexes the data using both producer and ingestion timestamps. You can create custom real-time or batch-oriented applications that run on Amazon EC2 instances to process data from Kinesis video streams using open source algorithms or third-party applications. Kinesis video streams, how it works. So first, producer data. A producer can be any video generating device like security cameras, body-worn cameras, smartphone cameras, or dashboard cameras. They can also send non-video data such as audio feeds, images, or radar data. One producer can generate multiple streams. Producer libraries. These are software and libraries installed on devices that enable secure connection and reliable streaming. They support different streaming methods like real-time, slightly buffered, or after-the-fact media uploads. This is the core resource that transports live video data and optionally stores it. It handles time-encoded data including audio, video, depth sensing feeds, and radar feeds. Streams can be created through AWS Management Console or AWS SDKs. Consumers. These are applications that retrieve and process data from the stream. Called Kinesis video stream applications, they can process data in real time or access stored time index data when immediate processing is not needed. They can run on Amazon EC2 instances. Key features. Typically, each stream has one producer publishing data, but multiple independent applications can consume the stream simultaneously in parallel, providing flexible processing options. Kinesis video streams API and libraries. Kinesis video streams gives you APIs to create and manage streams. You can also use these APIs to read and write media data to and from a stream. The Kinesis video streams console helps with administration. It also supports live playback and video on demand. Kinesis video streams provides producer libraries that help in application code to extract and upload the data from the media sources to the Kinesis video stream. Producer API, sending data. So first is put media API, and this lets a producer write media data to a Kinesis video stream. The producer sends a stream of media fragments in a put media request. A fragment is a complete sequence of frames. The frames in one fragment do not depend on frames in other fragments. As fragments arrive, Kinesis video streams gives each one a unique fragment number, which increases over time. Kinesis video streams also stores producer side and server side timestamps for each fragment. This is stored as Kinesis video stream specific metadata. Consumer APIs. So first one is get media. So when using get media, consumers must identify the starting fragment. The API then returns fragments in the order they were added to the stream, increasing order by fragment number. The fragments have a structured format such as MKV, also known as Metrosca. Get media advantage. So get media helps applications that fail or fall behind to easily catch up. Applications can process archived data, and as the application catches up, get media continues to provide real-time media data. Get media from fragment list and list fragments. Though these are two more APIs, and these APIs are for offline consumers, often used for batch processing. They enable applications to identify specific video segments by time of fragment range and fetch those fragments for processing. The approach used by get media from fragment list and list fragments is good for MapReduce applications that need to process large amounts of data quickly and in parallel. So the following diagram shows the data flow for fragments and chunks during these API calls. When a producer sends a put media request, it sends media metadata in the payload and then sends a sequence of media data fragments. Upon receiving the data, Kinesis Video Streams stores incoming media data as Kinesis Video Stream chunks. Each chunk consists of the following: a copy of the media metadata, a fragment, Kinesis Video Stream specific metadata, for example, the fragment number and server side and producer side timestamps. When a consumer requests media metadata, Kinesis Video Streams returns a stream of chunks starting with the fragment number that you specify in the request. If you enable data persistence for the stream, after receiving a fragment on the stream, Kinesis Video Streams also saves a copy of the fragment to the data store. Data plane REST APIs. Kinesis Video Streams uses a cellular architecture. This provides better scaling and isolates traffic. Each stream is mapped to a specific cell in a region. When using data plane REST APIs, you must manage and map the correct endpoints yourself. This is done with endpoint discovery pattern. You start the endpoint discovery pattern with a call to one of the get endpoints actions. These actions are part of the control plane. If you are getting endpoints for media or archived media services, use get data endpoint. Use get signaling channel endpoint to get endpoints for signaling channels, WebRTC storage, or Kinesis video signaling. Cache and reuse. So cache and reuse the endpoint for efficiency and make a fresh call to refresh it when the cached endpoint stops working. Uploading to Kinesis Video Streams. Kinesis Video Streams producer libraries are part of the Kinesis Video Streams producer SDK. The client uses this to build an on-device application. This application is for securely connecting to Kinesis Video Streams and streaming media data. You can view this data in the console or in client applications in real time. Media data can be streamed in real time after buffering it for a few seconds or after the media uploads. After you create a Kinesis Video stream, you can start sending data. The producer applications use the SDK to extract video data, which are frames, from the media source and upload it to Kinesis Video Streams. So I will just talk about a few of the important APIs. So first one is get media. So you can use the get media API to build your own applications to process Kinesis Video Streams. Get media is a real-time API with low latency. To create a player that use get media, you must build it yourself. For information about how to develop an application that displays Kinesis Video Streams using get media API, so you can check out these streams using parser library. Next one is HLS, which is HTTP live streaming, and this is an industry standard HTTP based media streaming communications protocol. You can use HLS to view a Kinesis video stream either for live playback or to view archived video. You can use HLS for live playback. Latency is typically between 3 to 5 seconds, but it can be between 1 to 10 seconds depending on the use case or the player and network conditions. You can use a third-party player such as Video.js or Google Shaka player to display the video stream by providing the HLS streaming video session URL, either programmatically or manually. You can also play back video by entering the HLS streaming session URL in the location bar of the Apple Safari or Edge browsers. MPEG dash. So dash stands for Dynamic Adaptive Streaming over HTTP, also known as MPEG dash. And this is an adaptive bitrate streaming protocol that enables high quality streaming of media content over the internet delivered from the conventional HTTP web servers. You can use MPEG dash for live playback. Latency is typically between 3 to 5 seconds, but it can be between 1 to 10 seconds also, depending on the use case, again, and depending on the player and the network conditions. You can use a third-party players, again, such as Dash.js or Google's Shaka player to display the video stream by providing the MPEG dash streaming session URL, both either programmatically or manually. And lastly, we have GetClip API. So you can use GetClip API to download a clip in an MP4 file containing the archived on-demand media from the specified video stream over the specified time range. And that's all. Thanks for watching.